In this video, we're going to examine a /24 subnet mask and see how it applies to an IP address. In this case, we've changed the color scheme a little bit, and we're now using red for network, and we're going to use gold for host. So we've got a nice even break right at the dot. I always like to say it's right at the dot. And this makes our life really easy. And this is a /24 once again because the first 24 digits of the subnet mask are set to 1, which corresponds to the first 24 digits of the IP address, which are set to whatever, but they have to be those same 24 bits exactly in order to be in the same network, which leads us to, okay, well, how is it that the subnet mask, being all of these ones, equals 255, 255, 255, 0? And the answer is actually, well, it's pretty simple. If we take the mask with byte by byte perspective, the first 8 bits together make up the first byte. And if we were to add up the binary value of each one of those positions, that would be the 128 position. The 8th position has a 1. So we would add that to the 7th position, which has a 1, which would be a 64, which we would add to the 3rd position, which would be a 32, and then a 16, and then an 8, and then a 4, and then a 2, and then a 1. And that's going to give us 255 in binary, or excuse me, in decimal. So that's going to equal 255. How do we end up with 0? No big deal, because we have 8 zeros over here on the host section, which just means that the whole final byte is going to be part of that network. So we now know where the numbers 255 and 0 come from. Later, we're going to subnet not at the decimal dot, but within a byte itself, and you're going to see how things are going to change. For now, this one's pretty easy. You can see it's a /24. The first 24 digits have to be formatted exactly as listed here to be in the same network. 1 1 6 zeros, 1 0 1 0 1 0 0 0 0 1 1 0 0 1 0 0. All has to be exactly the same to be in the same network, to be in the same subnet. The final 8 digits doesn't matter. They're all going to be in the same network. The lowest possible combination of numbers that we could get with those last 8 digits would be 8 zeros, right? So that would be 1, 2, 3, 4, 5, 6, 7, 8 zeros, which would give us a decimal equivalent to 0. And the highest possible address that could be in this same network, which would have to start with 192.168.100, would be 8 ones, would be 1, 1, 1, 1, 1, 1, 1, 1, which would equal, and we just went through this, which would equal 255. So this particular network, the number of addresses in a /24 network is 256 total addresses, because you're going to count the 0 value. So 0 through 255 would be the whole network. Of course, the very first address in any given network is called the network ID. I'm just going to write net ID right here. The network ID, and you cannot use that one for hosts. So that's the one that you cannot use. It's overhead for the network, mainly because you're going to use that value when you identify it and say, oh, well, hey, what network is that? It's the 192.168.100.55/24. And you go, what? No, just use the first number in the range. So, hey, what is that? It's 192. We're going to use 192.168.100.0/24. We're just going to use the first value in the range. That's going to be called our network ID. Now, there's a functional value for the last address in any given range, and that is called the broadcast ID. And in this particular case, the broadcast is going to be 255. So I'm just going to write bcast right here. The bcast ID is going to be, in this case, for this network, 192.168.100.255. That would be the broadcast value. If you wanted to send a broadcast message to everybody in the subnet, all the hosts in the subnet, you would use that address, 192.168.100.255. That would then pass to all of the devices that are on that particular network.